Okay, let's do some more for fun. Here we are going to integrate perhaps one of the most requested integral, namely the integral of x squared plus 20 over x sin x plus 5 cos x in this parentheses, and then we square that. If you would like, yes, please pause the video and try this first. If you don't like, it's okay. First, give me a like and then watch my solution. Thank you. Here is the trouble. If you just go ahead and do u sub or whatever sub that you want, and maybe even integration by parts, I don't think it's going to work out, right? And this is how we are going to do it. Here's the deal. Here we have sin x and here we have cosine x, and even though they have things in front of them, that's okay. The truth is that we can actually write these two terms into just a cosine function. Something in the front and then some new things as well. Let me show you what I mean by that. This right here is called the harmonic addition theorem. And let me just write down the theorem statement for you guys. You guys can find the video in the description box. So here is the statement. When you have a times sine x plus b times cosine x, you can actually combine this into just one cosine function, but you do have something in the front. Let's just call that to be capital A. And then here is that cosine function I was mentioning. And then the x stays the same, but you will have to subtract an angle, and let's call this angle to be phi, like this. And now you might be wondering what A and phi. Of course, I will show you. If you want to see the proof, check out the video. The A right here is just a square root of a squared plus b squared. And for the angle phi, we'll be using the inverse tangent. And pay attention. A is in front of the sine, right? So we'll use the inverse tangent to help us find out angle phi. Inverse tangent of A over B, like this. Yes, we'll be using the inverse tangent along the way, but you'll see the denominator will actually simplify much better. Let's take a look at this again. Originally, we had x times sine x plus 5 times cosine x. And now let's just use this right here. First, the capital A is just the square root of this square plus that square. So we have the square root of x squared plus 5 squared. And then we have the cosine, and the x right here stays the same, minus phi, which is the inverse tangent of, in our case, x over 5. So let's just put that down right here. Yes, we have the inverse tangent, but this is actually just one term. When you put this back to the denominator, good things will happen. So let's get to work. That's the first step. So here we go. This is the integral now. We have, let's put on the denominator first, which is just all that. So let me write down the square root of x squared plus 5 squared is 25. And then we have the cosine of x minus inverse tangent of x over 5, like this. And of course, don't forget the square, and don't forget the fraction partial being black. And then the dx. Don't forget the top as well. Okay, just like that. Now, let's just do some algebra. Why not? Let's take care of the square in the denominator, because now I can just pretty much square this and square that, right? And let's see, integral. Let's work this out first. We pretty much will have cosine square of this in the denominator, and let me bring that up, which becomes secant square. So this part square is just secant square of the inside, which is x minus inverse tangent of x over 5, like that. And then on the top, we still have the x squared plus 20. And then of course, when you take this, square that, you just get x squared plus 25 dx right here, of course. And now, if you want to feel better about this question, you should pause the video at this stage and try to finish it. Go ahead, do so. Take a break. All right, this is how we are going to finish it. It's not that bad at all. Here we have secant square of this crazy thing inside. So why don't we try u sub, let u equal to this guy, and hope for the best, right? So let's put that in action. Let u equal to this guy, which is x minus the inverse tangent of x over 5. And then let's just differentiate both sides, of course. We get du equal, this is 1 minus the derivative of this, which is 1 over 1 plus this thing squared, which is x over 5 squared. And what do we need? Yes, the chain rule, right? So by looking at the inside, multiply by the derivative of that, which is 1 over 5. So that's the chain rule part. And then I'm going to leave this to you guys, just do some algebra, get the common denominator whatsoever. All right, square this, clear the complex fraction, all that. And yes, you guessed it. This right here will turn out to be exactly x squared plus 20 over x squared plus 25 dx. Just work this algebra out, right? So this is so nice because this is u, this is du. Of course, you can totally take this integral to the u world. So here we have the integral of secant square of just a u inside. And then this guy is just my du. Can you be my du? Yes, you can. So that's what we have. And how do we integrate secant square? Yes, just tangent. So here we have tangent. This is the regular tangent, by the way. And then u inside, of course. But of course, let's just put down the u, which is this guy. So let's put down x minus the inverse tangent of x over 5. Whew. And if you want to stop right here, I'm not going to stop you because this is pretty nice. But the truth is, you know how did people come up with this kind of questions? Well, they start with a crazy looking expression and then they just differentiate it. If things cancel a lot, you end up with a really nice result. And if you want to integrate that, that becomes a crazy integral like this. So the idea, the more behind that is that this integral and then the answer should look alike. I will show you. So let me put this down for you guys. In order to get this back to the sine, cosine, whatever, we'll be using the angle difference formula for tangent. So I will write that down for you guys, of course. So let's put this down on the side. I'm not going to put on plus c yet. That's not yet, okay? Anyway, here we go. Suppose I have tangent of a minus b. So let me just put on capital A minus capital B. This right here is equal to tangent of a minus tangent of b. Why do I put parentheses? I don't remember about it. It's okay. And then 1 plus tangent of a times tangent of b, like this. I know I haven't put down the parentheses. Yeah. All right. With that being said, let's put this down in action. So this right here, this is our first angle, and that's the second angle. Don't forget the output of an inverse trig function is an angle. So let's see. I will have tangent A first, namely tangent x. On the top here, first let's put down tangent x. And then we are going to minus tangent. And the second angle is that, which is the inverse tangent x over 5, like that. And yes, they are going to cancel out. Very nice. And on the bottom, we have 1, and then plus tangent of the first angle, which is x. And then multiply by the second angle, which is tangent of that angle, which is inverse tangent of x over 5, like this. Right? Make it pretty and all that for you guys. So, as I told you, this and that cancel out nicely, right? And of course, let's see, I can still fit one. Let's put it no, here. Tangent x, of course, is just sine x over cosine x. And then right there is minus x over 5. Because that's the only thing that we have left. And then over there, we have 1 plus, once again, this is sine x over cosine x. And then this right here is once again x over 5. So multiply by x over 5. In the end, we have a complex fraction, but we can just multiply the top and bottom by 5 cosine x, 5 cosine x. And you will see this times that, well, the cosine cancels over the 5, and then sine x. And then this times that, the 5 cancels, so we have minus x cosine x over this times that is still that, which is 5 cosine x, and then you add, well, the denominators cancel out with that, which is just x times sine x. So you see that this right here, it's pretty much this thing right here in the denominator, right? And of course, they just kind of mess around. They just differentiate this. And then, yeah, somebody can go ahead and check the answer by differentiation. I will leave that to you guys, right? Somebody can make a video and let us know. So this right here is the answer. In the end, of course, don't forget the plus c before I completely box the answer. Whew, feels so good, isn't it? Alright, so if you guys are new to my channel, please subscribe. Thank you guys so much. And as always, that's it.